Hi there. Today we are going to walk through a realistic DevOps interview focused on Microsoft Azure. This interview is not about listing Azure services from memory. It is about how you think, how you design systems, and how you handle real production situations in the Azure cloud. I will ask questions similar to what you would hear in an actual interview. Pause after each question and try answering out loud before listening to the sample response. If this format helps you prepare and sharpen your thinking, subscribe so you do not miss the next interview. Let's start with a few behavioral questions to understand how you work with Azure in real environments. Tell me about a time you ran a workload on Azure that did not behave the way you expected in production. What happened and what did you learn? A strong answer might sound like this. We deployed an application using managed services and assumed scaling and reliability would be automatic. Under real traffic, we discovered that default limits and quotas were much lower than expected. The system throttled requests and caused user-facing delays. The lesson was that managed services still require careful configuration and testing. Since then, I always review limits early and validate behavior under load before relying on defaults. Next question. Describe a time when you had to balance security requirements with delivery speed in Azure. A solid answer could be, we were under pressure to launch quickly, but the system handled sensitive data. I focused on getting the security fundamentals right first, such as identity-based access, network isolation, and secret management. Some advanced features were deferred, but the core security posture was solid. I documented the risks and follow-up work clearly, so speed did not come at the cost of blind spots. That balance helped us move fast without creating long-term exposure. Next behavioral question. Tell me about a time when cost optimization became an issue in Azure and how you addressed it. A thoughtful answer would be, we noticed steady cost growth that did not match usage. After reviewing Azure cost reports, we found idle virtual machines, unused disks, and over-provisioned databases. We introduced tagging standards, budgets, and regular reviews. We also adjusted scaling rules and moved some workloads to lower-cost tiers. The experience reinforced that cost management is an ongoing operational responsibility, not a one-time task. Next question. How do you handle learning a new Azure service when it becomes critical to a project? A mature answer might be, I start by understanding the core purpose of the service and its common failure modes. I read official documentation, but I also look for real-world usage patterns and limitations. I test the service in a non-production environment and observe how it behaves under stress. The goal is not to master every feature, but to gain enough confidence to make safe decisions in production. Final warm-up question. Tell me about a time when you had to explain an Azure architecture decision to a non-technical stakeholder. A realistic answer could be, I focused on outcomes rather than service names. Instead of explaining specific Azure components, I talked about reliability, cost control, and risk. I used simple comparisons to explain why certain choices mattered. That approach helped stakeholders understand the trade-offs without needing deep technical detail, and it made alignment much easier. Now let's move into the technical and scenario-based questions. Explain the difference between an Azure region and an availability zone, and why that matters for system design. A clear answer might be, an Azure region is a geographic area that contains one or more data centers. Availability zones are physically separate locations within a region designed to fail independently. Using multiple zones protects applications from single data center failures. Designing across zones improves availability without the complexity of multi-region deployments, which are usually more expensive and harder to manage. Next scenario. You have an application running on Azure virtual machines behind a load balancer. Traffic increases suddenly, and performance degrades. How do you approach diagnosing and fixing this? A strong answer could be, I start by identifying the bottleneck. I look at CPU, memory, disk I/O, and network metrics on the virtual machines. I check whether the load balancer is distributing traffic evenly and whether health checks are configured correctly. If the instances are saturated, I consider scaling out using a scale set. If scaling does not help, I investigate downstream dependencies like databases or external APIs. The goal is to find the constraint before making changes. Next question. When would you choose Azure Virtual Machine Scale Sets instead of manually managing virtual machines? A thoughtful answer might be, I choose scale sets when I need elasticity and resilience. Scale sets automatically handle instance replacement, scaling, and health-based actions. Manually managing virtual machines can work for small or stable workloads, but it increases operational overhead. Scale sets reduce that burden and make the system more adaptive to changing demand. Next scenario. Your application stores user-uploaded files and must be highly durable and scalable. How would you design this on Azure? A strong answer would sound like this. I would store user uploads in object storage rather than on virtual machine disks. Object storage is designed for durability and scales automatically. The application can upload files directly or through a controlled endpoint. I would also configure access control, encryption, and lifecycle policies. This design decouples storage from compute and simplifies scaling. Next question. How do you think about identity and access management in Azure when designing a system? A mature answer could be, I focus on identity first and avoid static credentials wherever possible. I use managed identities so services authenticate securely without secrets. I apply least privilege by granting only the permissions required for each component. Identity is a core security boundary in Azure, and getting it right reduces both risk and operational complexity. Next scenario, you deploy a change and some users report failures while others see no issues. There are no obvious errors. What is your first instinct? A realistic answer might be, I suspect a partial failure, often related to networking, routing, or zone-specific issues. I check whether traffic is unevenly distributed or whether some instances or zones are unhealthy. I review recent configuration changes that might affect only part of the system. Partial outages often indicate misconfigurations rather than complete service failures. Let's continue with the second half of the technical discussion. These scenarios focus on how Azure behaves under real load, how managed services fail in subtle ways, and how you reason through trade-offs when the platform does not behave exactly as expected. Here is the next scenario. Your application uses Azure SQL Database. During peak usage, users report slow responses, but CPU usage stays relatively low. What do you investigate? A strong answer might sound like this. Low CPU does not mean the database is healthy. I start by looking at concurrency limits, DTU or vCore utilization, and wait statistics. Azure SQL often bottlenecks on connections, locks, or I/O before CPU spikes. I check slow queries and blocking sessions. I also review connection pooling behavior on the application side because opening too many connections can cause throttling. Depending on what I find, I might tune queries, increase service tier, or adjust application connection handling. The key is identifying the real constraint rather than assuming compute is the issue. Next question. You are designing a system that must remain available even if an entire availability zone fails. How do you validate that your Azure setup actually meets this requirement? A thoughtful answer could be, I do not rely on architecture diagrams alone. I validate by testing failure scenarios. That might involve intentionally stopping instances in one zone and observing how traffic shifts. I verify that load balancers stop routing to unhealthy instances and that scale sets replace them correctly. I also test stateful components like databases and storage to confirm failover behavior. Without testing, zone redundancy is only theoretical. Next scenario. An application running in Azure App Service starts restarting randomly under load. Logs are incomplete and do not clearly explain why. What is your approach? A strong answer would sound like this. I start by checking resource limits such as memory and request quotas. App Service will recycle processes if they exceed limits or fail health checks. I review platform logs and application diagnostics to see whether restarts align with traffic spikes. I also check whether startup time exceeds allowed thresholds, which can cause restarts during scaling. If needed, I temporarily increase logging and reduce load to stabilize the service while I investigate. Understanding platform enforced limits is critical in managed environments. Next question: when would you choose Azure Kubernetes Service over simpler compute options like app service or virtual machines? A realistic answer might be: I choose AKS when I need orchestration features like fine-grained scaling, custom networking, or complex deployment strategies. It also makes sense when teams are already comfortable with Kubernetes and want portability. For simpler applications, app service or managed platforms reduce operational overhead. AKS adds flexibility, but also complexity, so I use it only when the benefits justify that cost. Next scenario: your system relies heavily on Azure storage. Suddenly, requests start timing out, but there is no clear outage reported. How do you reason through this? A thoughtful answer could be: I check storage metrics such as latency, throttling, and request rates. Azure Storage enforces limits that can be hit under bursty workloads. I look at whether access patterns changed, such as many small requests or hot partitions. I also verify network connectivity and retry behavior in the application. If throttling is the issue, I consider adjusting access patterns, adding caching, or requesting higher limits. Silent throttling can look like random failures if you are not monitoring closely. Next question: you are asked to design a disaster recovery strategy across Azure regions. The business wants fast recovery but is concerned about cost. How do you approach this? A strong answer might be: I start by clarifying recovery objectives. If recovery time needs to be very short, active-active architectures are possible but expensive. If some downtime is acceptable, I design an active-passive setup with warm standby resources. Data replication strategy depends on consistency needs. I also emphasize regular failover testing. A cheaper disaster recovery plan that is never tested is riskier than a slightly more expensive one that is well understood. Final question for this section: how do you decide which Azure platform risks to design around and which ones to accept? A mature answer could be: I design around failures that are common or have severe impact, like instance failures, zone outages, and misconfigurations. Extremely rare platform failures may be acknowledged but not fully engineered around if the cost is too high. I document these assumptions and make sure stakeholders understand them. Designing systems in Azure is about managing risk intelligently, not eliminating it entirely. Let's move into the pressure section. These scenarios are intentionally ambiguous and uncomfortable. They are designed to see how you reason when Azure behaves unpredictably, information is incomplete, and the impact of a bad decision is real. Here is the first scenario. Your production application runs across multiple availability zones. One zone starts showing intermittent failures and elevated latency, but Azure has not declared an official incident yet. Users are complaining, but the system is not completely down. What do you do? A strong answer might sound like this: I focus on protecting user experience first. If traffic can be shifted away from the problematic zone without causing additional risk, I do that immediately. Then I compare metrics across zones to confirm whether the issue is localized. I avoid waiting for an official platform announcement before taking action. At the same time, I keep stakeholders informed that we are mitigating impact while investigating. Stabilization comes first. Root cause analysis comes after the system is under control. Next scenario: your Azure bill spikes dramatically over a short period of time. You suspect an auto-scaling misconfiguration, but production traffic is still flowing. Leadership wants the cost reduced immediately. How do you handle this without breaking the system? A thoughtful answer could be: I start by identifying what is driving the cost increase. I look at which services are growing and whether the usage aligns with traffic. If I find runaway scaling or unnecessary resource creation, I cap it carefully rather than shutting things down abruptly. I communicate clearly that we are reducing risk while preserving availability. Cost incidents require urgency, but they also require caution. A rushed shutdown can cause more damage than the bill itself. Next pressure question. A security review discovers that a managed identity in production has broader permissions than it should. Tightening the permissions might break several workloads. Leaving it as is increases security risk. How do you make this call? A mature answer would be, I assess the severity of the exposure first. If the risk is actively exploitable, I prioritize fixing it even if it causes disruption. If the risk is theoretical, I plan a staged rollout where permissions are reduced incrementally and monitored closely. I also add compensating controls where possible, such as additional logging or alerts. The key is not ignoring the issue and not creating unnecessary outages. I make sure the risk and plan are clearly communicated. Next scenario. Azure reports a partial outage affecting a service your application depends on. Some features are broken, but core functionality still works. You have the option to fail over to another region, but that process is risky and expensive. How do you decide? A strong answer might be, I weigh impact against confidence. If the outage is causing unacceptable user impact and we have tested failover recently, I am more inclined to proceed. If failover has not been exercised or data consistency is uncertain, I may choose to degrade features instead and wait. I also consider how long the outage is likely to last based on available information. Whatever decision I make, I communicate it clearly and commit to it. Indecision often causes more harm than a well-reasoned choice. Final pressure scenario. You are leading an incident response, and different engineers propose conflicting solutions. Some want to make aggressive changes. Others want to wait for more data. Time is passing. How do you lead the team? A realistic answer could be, I take ownership of decision-making. I listen to the proposals, but I choose a clear path forward based on risk and reversibility. I favor actions that are safe and reversible first. I also make sure roles are clear, so people are not working at cross purposes. During incidents, alignment matters more than perfect solutions. Once the system is stable, we can revisit deeper fixes. That brings us to the end of this Azure-focused interview. These scenarios reflect how real cloud incidents feel, where the platform is complex, information is imperfect, and every choice has trade-offs. What matters most is how you think, how you communicate, and how you prioritize safety under pressure. Take a moment and reflect on which question challenged you the most. Was it deciding when to fail over, balancing cost against availability, or handling security risk under time pressure? If this format helps you prepare for real interviews and real incidents, make sure you subscribe so you do not miss the next session.